In the United States Air Force, the accepted margin of error for an unauthorized nuclear detonation or the degradation of a weapon system is 0%. Managing that absolute risk requires a flawless, mathematically rigid organizational architecture. This formation of B-52 bombers represents the physical scale and strategic weight of the American nuclear triad. When dealing with these systems, the margin for systemic error effectively vanishes. To maintain that standard, the Air Force uses nuclear certification. This continuous, unforgiving life cycle dictates the status of every nuclear asset from design until retirement. Achieving this status requires the simultaneous completion of two entirely separate, rigorous verification processes. Without an architecture that verifies both the machine and the operator, a single hidden flaw in either could trigger a strategic catastrophe. This framework is built on two axes. The first pillar, design certification, validates the engineering of hardware and software. The second pillar, operational certification, focuses on human and organizational elements. These two axes must perfectly align to achieve a certified state. The ultimate authority governing this framework is the Master Nuclear Certification List, or MNCL. The MNCL is the official Air Force listing of all nuclear certified items, excluding procedures. The MNCL functions as a binary ledger. A physical asset is either a perfect match to an entry on this list or grounded. The Air Force's greatest vulnerability is a perfect machine operated by an uncertified unit. The dual-access approach is the only viable defense against that threat. The design certification pillar expands into a four-part architectural tree owned by the acquisition program manager. Their job is to ensure the system itself is technically sound. The first component is compatibility. The Air Force Nuclear Weapons Center, or AFNWC, verifies the physical, functional, and environmental interfaces between the weapon and its delivery vehicle. The second node is nuclear safety design. The Headquarters Air Force Safety Center, or AFSEC, mandates strict compliance with safety criteria and documents all residual risk. The third component is the implementation of Weapon System Safety Rules, or WSSR. WSSR are operational restrictions approved by the Undersecretary of Defense to enforce nuclear surety standards across the entire stockpile to target sequence. The final node covers technical orders, or TOs. Technical orders are the official, step-by-step military manuals governing how equipment is used and maintained. Before this node is cleared, the Technical Order Management Agency must verify every single operational and maintenance procedure for the system. A machine achieves design certification only when every physical edge case and software vulnerability has been systematically neutralized on paper. This photograph shows the human operators who interface with these systems inside a missile silo. Their proficiency is as critical as the hardware itself. This brings us to the operational certification pillar. This axis is owned by the lead or using command overseeing the personnel. The first hurdle is task-specific qualification training. This ensures the crew is technically proficient on the exact weapon system they are assigned to operate. The second node is the Personnel Reliability Assurance Program, or PRAP. PRAP is the continuous psychological, medical, and behavioral evaluation protocol required to trust an individual with nuclear duties. The final two nodes are Nuclear Certi Training and the Initial Nuclear Certi Inspection, or INSI. An NSI is an evaluation where a unit must achieve a ready rating through flawless performance. A perfect hardware architecture is effectively useless if the human element introduces unverified variables into the chain of command. How do commanders know exactly which of these 8 nodes must be verified for a specific modification or a new system? They follow the Certification Requirements Plan, or CRP. The CRP is a formal document that defines the specific requirements and tasks needed to achieve certification across 4 distinct phases. It starts with the identification phase. This is where the CRP is drafted to determine if a new asset or modification impacts nuclear surety. Next is the execution phase. This is the gauntlet where every requirement outlined in the CRP must be tested, analyzed, and proven. The fielding phase is triggered only when both the design and operational certifications intersect successfully. Once these certifications align, the AFNWNC issues a singular nuclear certification summary. The CRP provides the mathematical proof that the machine's capabilities are perfectly synchronized with the operator's readiness before deployment. Once the nuclear certification summary is issued, the asset is inscribed into the Master Nuclear Certification List. The MNCL is the sole authority for verifying certification status. No other local database or software tracker is legally valid for determining if an item can be used in nuclear operations. Units must perform 100% annual physical verification of all nuclear certified equipment against the MNCL database. Physical compliance is absolute. If even a single character on an equipment data plate mismatches the MNCL, the certification is voided. When multiple identification elements are present, every single available element must align perfectly with the ledger to authorize use. A perfect match to the MNCL is the only difference between an operationally ready asset and a grounded piece of metal. This brings us to the final life cycle phase, sustainment. Nuclear certification exists as a fragile equilibrium, requiring constant monitoring to prevent systemic decay. Once an asset is fielded, it faces the friction of reality. Hardware experiences wear and tear, and software requires constant updates. Maintaining safety requires strict reporting, primarily through dull sword reports. Dull swords are reports of minor incidents involving nuclear weapons, components, or systems, which could impair their deployment. When a deficiency is reported, the affected asset immediately loses its certified status. These reports kick the system back to the identification phase, starting the entire CRP process over again to verify safety. The UASF Nuclear Certification Program secures the globe through the physical precision of the MNCL and a rigidly enforced architecture that assumes perfection is always temporary.